Okay, guys, so I just want to start off, first lesson, first homework, getting used to it. Chapter 1 covers a lot of stuff, as does Chapter 2, and we're going to spend some time going through them, but primarily we're going to focus on the latter chapters, Chapters 3 and on. But I did want you to remember some of your algebra skills, as it does play a part later on. So on our first problem here, use point-by-point plotting. So I'm going to click on my graph here. Now this is a straight line. If you remember our rules, that since y has a power of 1 and x has a power of 1, it's a straight line. And this is our slope-intercept form of y equals mx plus b. So this is my y-intercept then. That minus 4 is my y-intercept. Let me see if I can make that a little bigger. There we go. So what I'm going to do is come over here and I'm going to use my tool. I'm going to draw a straight line. So I'm going to click on the line tool. And I'm going to put my first point right here at -4 on the y-axis. So come on down to -4 and then click and it puts the point. And now I can put my second point where I need. So let's take a look. My slope here is 1, right? Because it's 1x, which means I go over 1 and up 1 and I can plot the next point. Or I could just pick any point I want. Pick any number you like for x. Let's say 6. Okay, I can pick any number, but I'll pick 6. So if x is 6, 6 minus 4 is 2. So when x is 6, y is 2. I plot the second point, save, check my answer, and I'm good to go. Okay, let's take a look at one where we're looking at a slightly different problem now. Make this a little bit bigger. Indicate whether it's a function or not. So remember what function says is that every x value goes to only one y value. Now if you look here, we say, oh my god, they're all going to 4, and that's fine. We can have more problems go to the same number. We just can't have one value of the domain going to 2 different y values. Okay, so in this case, you know, if I was looking at a computer program for this picture, it's just no matter what number you type in, the answer is always 4. There's no discrepancy, there's no confusion. Okay, so for example, let's take a look at this one. Let's see what the next question has. So now look at this one. Right here with -4, we see -4 goes to 2 different places, and that's what makes it no good. Okay, if the question was asked, or if the computer program says, you know, you typed in the number -4 and now the computer does not know which answer you want. Do you want the 6 or do you want the -5? So there's confusion, which means it is not a function. Okay, we can take a look at one where we have a straight line. Again, this is a y equals mx plus b. If we rearrange it a little, right, bring the 2x over, so we can add 2x to the other side, make it y equals 2x plus 4, which means it is a straight line. It is linear, and a straight line is always a function. But since it's linear, we can just select it's a linear function selected by the equation. We're good to go. Constant means if I had something like y equals 2. Okay, no x value. Remember what a constant function would look like on a graph. If I have, hang on, let me bring this up for a second. This is just paint. Sorry about this, but it just works easier. I'm using a mouse, so bear with me. If here's my axis, here's the line y equals 2. Right? That's a constant function. No matter what value of x you pick, you could pick x equals any number, 1, 2, 117, -3000.4. Y is always equal to 2. Y is constant. This is still a function though, right? Because look, if I draw my lines going vertically, I only hit the graph in one place. Notice that our other constant function, if I have the line x equals 4, this is not a function, because for this one value of x, when x equals 4, I get many values of y. I get y equals 1, 4, 2, 4, 3, 4, 4, etc., and so forth. Okay, so that would not work as a function. So this one we got linear, we could check, and we're good to go. Let's see about this one. just trying to go through a couple, and hopefully you're looking at the notes, but these are some of the basic ones. But now let's look at the quadratic, because now we have a power of 2. Now remember what powers mean. The powers tell you how many directions it goes in. And we basically have a couple different ones we can use, right? We've got y equals x squared, which is 2 directions. First your graph goes down, and then your graph goes up. So it's in 2 directions, right? And it's your U-shaped curve. Now we do put the arrowheads on both sides because the graph continues in both directions, but realize, as I'm going from left to right across my screen, this graph is going down first, and then it's going up. And that's what my power is telling me. If I were to change it up and make it negative x squared, well, instead of going down and then up, it would go up and then down. Okay? Again, notice as I go from left to right, it's going up and then it's going down. Now the ones we don't use too much, or as much I should say, is when we switch the variables. So if x is squared, means it goes 2 directions on the y-axis, right? It's going up and down, which is the y-axis. If I flip it, if y is squared, it means it'll go 2 directions on the x-axis. It'll be sideways. Same idea though, okay? But now in this case, we're going left, and then we're going right. And lastly, of course, if y is negative, it'll have it go in the other direction. And I missed. That should be through the origin. Okay, let's make it bigger. So knowing that, let's take a look. Now this one says use a graphing tool. A little bit trickier using the graphing tool, but here's my line, tells me, here's my absolute value, here's my parabola. So let's click parabola, and it says click the graph to plot the first point. Well, let's look at that first point. Well, notice here it's still the same thing. This is still my y-intercept, because if I plot points, if x equals 0, I can make a table of values. If x equals 0, I get 0 plus 6, which is 6. So if x equals 0, then y equals 6. There's my first point. Whoops. Why is it not going there? Let's do that again. And then we could just pick more points. Let's let x equal, you know what, I might have to plot a point first, but let's see. Let's let x equal 1. If x equals 1, 1 squared is 1, becomes negative. So negative 1 plus 6 is 5. When x equals 1, y is 5. And then I could use when x is negative 1. If x is negative 1, then negative 1 squared is positive 1, makes it negative again. Negative 1 plus 6 is again 5. And there's my graph. Okay? And I probably could have just easily picked when x was 2. 2 squared is 4, makes it negative 4, plus 6 gives me 2. So at 2 comma 2, I could have put the point, and I'm sure it would have worked out as well there. Okay? Let's see. Use points on a graph to identify the input. I don't know if I specific. Oh, we can take a look at this one. It's not too bad. This graph is asking. Let's make it a little bigger. Find the value of f of negative 2. Now remember, this is the x value. Okay? Find the value of f, which is the same exact thing as saying y. What does y equal when x is negative 2? So let's go to the graph. When x is negative 2, I'm right here. And now I'm going to go up until I hit the curve, which looks like right here. And what is that y value? Well, come across, and it looks like it's going to be at 5, 6, 7. So it looks like y has a value of 7. Okay? Again, this is the x they want me to look at, so I go over to that x value. I go up or down until I hit the blue line. So for example, if this had said positive 2, I would have come over here, and then I would have come down until I hit the graph and seen the y value. Okay? Domain, we could do a quick one of these. Just doing a quick one of each example just to help you out. What is the domain of the function? Well, for this, it's a little bit easier if you remember what it looks like. And if you don't, you could always go to something like desmos.com, which is a free graphing utility. But really, we only need to look at the lead term. And in this case, it's 2x to the third power. So since it's x to the third power, it's going to go in 3 directions. And since it's positive in front, then it's going to finish going up. So basically, my graph is going to look something like this. Notice I have 3 directions. First, again, as I go left to right, first I'm going up. That's one direction. Then it's going down. That's my second direction. And then I'm going back up. 3 directions. And there's your power of 3. Now my domain is asking how far to the left. Remember, domain just means how far to the left does this graph go and how far to the right does this graph go. And hopefully you could see that this graph will continue to go all the way to the left. It'll continue to go all the way to the right. And therefore it has a domain of negative infinity to positive infinity. The domain ones are a little bit trickier, but they are important later on when we start to look at our functions, because there will be places where the domain does not exist and therefore we cannot work with it at that point. And let's see, how about last one here? Last example, basically find and simplify f of x. Again, that just means y. Y equals x squared minus 4 if you want to write it down. Y equals x squared minus 4. Instead of f of x, same thing. And now this is saying that x is 4. Okay? It's f of x, and now they're saying 4. So basically all they're saying is that x equals 4. What does y equal? And so let's just plug it in. Again, sorry it's sloppy. Writing with a mouse is not my specialty. 4 squared is 16 in this country. 16 minus 4 looks like 12. And we're done. Okay, so there's homework of section 1, some examples from each. Hope that helps you out, and if not, please be sure to ask me questions.